Somewhere right now, you are lying down or settling in or closing your eyes, and you're about to travel back further than most people ever think to go. Not hundreds of years, not thousands, millions. The story of where we came from, of how creatures that once lived in trees slowly became the kind of beings who build cities and write songs and wonder about their own existence, is one of the longest and most quietly astonishing stories ever told. And tonight, we are going to tell it from the very beginning. Before we go any further, we would love to know where you are listening from right now. Drop a comment and tell us your location and what time it is there. Whether you are drifting off in a small town somewhere in the middle of the night or winding down after a long afternoon on the other side of the world, knowing that this story is reaching so many different places at once feels like something worth pausing on. Now, the question of where humans come from is one that scientists called paleoanthropologists have spent their entire lives trying to answer. They do it by reading the past through the things it leaves behind. Fossils, fragments of ancient bone pulled from the earth after millions of years of waiting, stone tools, cracked and shaped by hands long gone, and more recently, genetics, the invisible code written inside living DNA that carries echoes of ancestors we have never seen. Together, these pieces form a picture that is never complete, but is always growing more detailed, more surprising, and more humbling. What that picture shows us is this: the journey from our earliest ape-like relatives to the first true human beings took an almost incomprehensible span of time, and it was not a straight road. It wound through dozens of species, across shifting climates, through forests and grasslands and volcanic valleys. Some of those species survived for millions of years, others vanished quickly. All of them played some role in shaping what came next. So settle in, get comfortable, let your breath slow down. The story begins long before the first humans ever appeared. The world is still ancient, still green and hot and alive in ways that feel almost unrecognizable. It is somewhere between 4 and 2 million years ago, and Africa is a continent in motion. Tectonic plates are shifting beneath the surface. The Great Rift Valley is deepening, cutting a long scar through the eastern part of the continent and changing the climate on either side of it. Forests thin out in places, grasslands spread, and in that slowly opening landscape, something is learning to move in a new way. These are the Australopithecines, a group of early hominins whose name comes from the Latin for southern and the Greek for ape, southern ape. And for a long time that name seemed to fit, because in many ways they still look the part. Small skulls, large faces that jutted forward, arms that were long relative to the body, fingers that were curved in a way that still knew how to grip a branch. But there was something different about them, something that would turn out to matter enormously. They were walking upright on 2 legs. Bipedalism, it sounds simple, but think about what it actually means. Before this, the ancestors of these creatures moved through the world on 4 limbs, climbing, swinging, knuckling along the ground. Walking upright was a complete reorganization of the body. The pelvis tilted and widened, the spine curved into an S shape to balance the weight of the head over the hips. The heel thickened, the big toe pulled inward, aligning with the other toes to act as a lever for forward movement, rather than a grasping tool for branches. These were not small changes. They were a full architectural redesign. Why did it happen? There's no single answer that everyone agrees on. Some researchers believe it had to do with energy efficiency, that walking on 2 legs required less effort when moving long distances across open ground. Others point to the freeing of the hands, that standing upright allowed these early hominins to carry things, food, infants, perhaps eventually tools. Some suggest it helped with thermoregulation, allowing the body to catch cooler air higher above the hot savanna ground. It may have been a combination of all of these, a gradual accumulation of small advantages that added up over generations into something transformative. And then, in 1974, a discovery in the Afar region of Ethiopia changed the way we understood all of this. A partial skeleton, about 40% complete, pulled from ancient sediment. Scientists named her Lucy, after the Beatles song that was playing in camp the night of the find. Her scientific name was Australopithecus afarensis. She lived around 3.2 million years ago, and she was small, just over a metre tall, perhaps 29 kilograms. Her brain was roughly the size of a chimpanzee's. Her face was ape-like, with a protruding jaw and a low forehead. But her knee joints, her hip bones, the very angle of her femur told a clear story. She walked upright, not perfectly, not with the long, efficient stride of a modern human, but she walked. And a few years after Lucy was found, fossilized footprints discovered at Litolia in Tanzania confirmed it. Two individuals walking side by side across a field of volcanic ash 3.6 million years ago, leaving prints so clear they could have been made yesterday. But Lucy was not alone in her world. Australopithecus was not a single species. It was a genus, a family of related but distinct creatures that lived across different regions and different time periods. There was Australopithecus africanus, found in South Africa, with a slightly rounder skull. Australopithecus sediba, discovered only in 2008, with features that seem to blend earlier and later characteristics in puzzling ways. Possibly others still waiting beneath the ground. The picture is full of overlaps and gaps and ongoing debates. Scientists are still working out which species led to which, and whether some of them are even distinct species at all. What we can say is that these were creatures living at the edge of two worlds. They probably spent some time in the trees, sleeping there at night perhaps, away from predators that moved silently in the dark. But they also moved across the ground, through woodlands, along river valleys, into more open terrain. They ate a wide variety of foods, roots, fruit, leaves, possibly insects, perhaps scavenged meat on occasion. Their teeth were large and their jaws were powerful, suggesting a diet that required real grinding force. Life was not easy. They were small. They were not fast. Leopards hunted them. Eagles took their young. The fossil record carries the marks of these encounters in bone, and yet they survived. For millions of years, these creatures walked across a continent that was always changing around them. They did not know what they were becoming. They had no concept of a future unfolding. They simply moved through the world as it was, adapting, persisting, passing something forward to generations they would never see. Small-brained, upright, and alive. The first step taken in the longest walk in the history of our kind. Time moves on. Seasons turn over millions of years. Volcanic ash falls and hardens. Rivers carve new channels. The Australopithecines keep walking, generation after generation, their small brains protected by thin bone, their bare feet pressing paths through grass and dust that will never be seen again. But gradually, quietly, something starts to change. Around 2.4 to 2 million years ago, in parts of East and perhaps Southern Africa, a different kind of hominin begins to appear in the fossil record. The bones are scattered, incomplete, blurred by time. But taken together, they hint at a shift. These creatures are still small by our standards, maybe a little over a metre tall, maybe more. Their faces still project forward. Their arms are still somewhat long. If you saw one from a distance, you might mistake it for a slightly built Australopithecine. And yet, if you looked closer, especially at the skull, you would see something new. The brain case is a little larger. Not huge, not human, but clearly bigger than Lucy's kind. Something like 500 to 700 cubic centimeters of brain instead of 400 or so. The shape of the skull changes too, rounding slightly, pulling inward in the face. The teeth are a bit smaller and more human-like, and the hands, where we have them preserved, seem more capable of fine movement, with thumbs better suited for gripping and shaping. These remains are given a name: Homo habilis. Handy man, the first member, many think, of our own genus. The name itself reveals how we first came to understand them. Because near bones like these, in places such as Olduvai Gorge in Tanzania and Kubifora in Kenya, another kind of evidence appears. Scattered among the sediments are pieces of stone, broken in a way that is not random, angular fragments with sharp, cutting edges, cores with flakes removed in patterned ways. These are the earliest widely recognized stone tools made by hominins. Archaeologists call this tradition Older One, after Olduvai. On the surface, they look simple. A rounded cobble struck with another stone to remove a flake. The flake itself, thin and sharp, used like a primitive knife. The leftover piece, the core, sometimes used as a pounding or chopping tool. No handles, no polish, no complex shaping, just fracture, edge and function. But that simplicity hides something important. To make even a basic Older One tool, you need to recognize which rocks will break the right way. You have to choose a stone with the right hardness and structure, maybe a volcanic rock like basalt or a fine-grained material like quartzite. You have to understand how to strike it, at what angle, with how much force, where the blow will travel through the stone. You have to predict, at least roughly, what kind of edge you will get. This is more than accident. It suggests planning. It suggests that in some early hominin mind, there is an image of a sharp edge that does not yet exist, and a sequence of actions that will bring it into being. With that edge, the world changes. Before stone tools, an animal's body is limited by its teeth, its claws, its jaw muscles. What it can cut is what its bones allow. What it can open is what its hands can tear. Older One tools extend that range dramatically. A flake can slice skin, cut meat from bone, split tendons. A hammerstone can crack open long bones to reach the rich, fatty marrow inside, or smash tough nuts and tubers. For a creature like Homo habilis, this means new possibilities. The savannah is full of carcasses left by lions, hyenas, and other predators. Without tools, much of that resource is locked away. Thick hides, big bones, layers of sinew. With tools, these become accessible. A group of small hominins can arrive after larger carnivores have eaten and still find something worth taking. This is scavenging, and many scientists think it may have been a key part of Homo habilis' life. We can imagine a scene. A leopard kills an antelope and drags it into the brush. Hours later, vultures circle overhead. The smell of blood drifts across the wind. A small band of Homo habilis, moving through the mosaic of woodland and grassland, notices the calls of the birds. They approach cautiously, watching for the leopard's return. When they judge the risk low enough, they edge in. They do not have big claws or long canines, but in their hands they hold rocks with sharpened edges, carried from some distant riverbed. Kneeling beside the carcass, they slice through the remaining strips of meat. They break bones, they scoop out marrow, they carry what they can back to a safer place. They eat quickly, nervously, always aware that at any moment a larger predator might appear. In this kind of life, social cooperation matters. A lone individual is vulnerable. A group, even a small one, has more eyes, more warning, more ability to intimidate or at least confuse a rival scavenger. We don't know exactly how Homo habilis organized itself. They probably did not have language as we know it, but they almost certainly communicated through calls, gestures, postures, and perhaps simple vocal patterns. Some may have watched while others fed. Some may have carried tools while others carried infants. Sharing food, even in small, irregular ways, could have knit the group together. A successful scavenger would not only feed itself, but perhaps also others, deepening social bonds that would matter the next time danger appeared. Compared to Australopithecus, Homo habilis seems poised between worlds. The body still carries evidence of climbing. The shoulders and arms suggest that trees were not yet abandoned. Nights may still have been spent off the ground, in the safety of branches, away from the eyes of hyenas and the teeth of big cats. During the day, though, these early members of Homo likely ranged farther across open ground, following watercourses, watching for circling birds, searching for carcasses, roots, fruit, and edible shoots. Their diet was probably more varied than that of earlier hominins, with meat and marrow playing an increasingly important role. Animal remains found at some older one sites show cut marks from stone tools, sometimes overlaying tooth marks from other predators. This layered evidence suggests a complex dance of timing. Who gets to the carcass first? Who arrives second? Who stays long enough to leave their mark? Their brains, though still small, were growing. A difference of a few hundred cubic centimetres might not sound like much, but when it comes to neural tissue, each increment opens new possibilities. Larger brains mean more energy demand, but also potentially more flexible behaviour, more capacity for memory, more room for the kinds of circuits that can hold simple strategies and pass them along. Hands, too, seem to be changing. Some Homo habilis fossils show a thumb that is relatively long and strong compared to the fingers, with joints suggesting a powerful precision grip. This is the kind of hand that can hold a pebble in just the right way, that can rotate a core, that can pinch a flake between thumb and finger, and use it delicately. Of course, not everything is clear. Homo habilis sits in a part of the fossil record that is crowded and confusing. Some bones originally assigned to Homo habilis have later been reinterpreted. Another species, Homo rudolfensis, with a larger face and brain but found in overlapping times and places, complicates the picture further. Some researchers wonder if what we call Homo habilis is not a single, neat species, but rather a cluster of slightly different populations, some more Australopithecine-like, some more like later Homo. In this view, instead of a sharp boundary, here Australopithecines, there humans, we see a long, messy transition. Different groups experiment with different body plans, different diets, different amounts of tool use. Some lineages may branch off and end, others blend. Over hundreds of thousands of years, the traits we think of as human do not appear all at once. They flicker into existence in patches, in combinations. Homo habilis, then, might be less a clear starting line and more a snapshot from the middle of a slow, uneven transformation. What is less debated is the significance of the tools, whether every old dough and flake was made by Homo habilis specifically, or whether some were made by late Australopithecines or early Homo erectus. The pattern is the same. At this point in the story, hominins are no longer just shaped by their environment. They are beginning to shape it in return. With tools, an animal can change what it can eat, and therefore where it can live. It can crack nuts that once were sealed, process plants that once were too tough, access animal parts that once were inaccessible. It can defend itself with something harder than bone, strike with something heavier than a fist. Toolmaking also changes the rhythm of life. Stones collected at one place might be carried for use at another. A particularly good cobble might be kept, reused, modified again. Knowledge about which stones are best and where to find them becomes important. Memory stretches a little further. The idea of a future need, I will want a sharp edge later, begins to take shape in the mind. Over time, gatherings of stone, bone, and ash begin to mark certain locations. Not permanent settlements, not yet, but places visited again and again, perhaps seasonally. These small, repeated acts, striking stone against stone, sharing food around a spot of cleared ground, are the beginnings of something that, far in the future, will become campsites, villages, cities. From a distance of 2 million years, Homo habilis looks fragile, provisional, half-formed, not yet committed fully to the ground or the trees, not yet hunter, not yet farmer, still deeply vulnerable to tooth and claw and flood and drought, and yet, in their minds and in their hands, a quiet revolution is underway. The first recognizable stone tools mark a turning point in the story of life on Earth. They are the initial visible trace of a lineage that will increasingly rely not only on teeth and muscles, but on ideas. Where other animals adapt over generations through changes in genes and bodies, these early humans are beginning to adapt within a single lifetime by changing the objects around them. A cracked stone on an ancient riverbank may not look like much, but it is the seed of everything that comes after. Spears and fires, boats and needles, ploughs and buildings, satellites drifting through a sky that these early hominins would never have imagined. For now, though, the world remains simple and harsh. The sun rises over open grasslands and scattered trees. Vultures spiral above distant carcasses. A small group of Homo habilis moves cautiously through the landscape, clutching a few precious stones, scanning for danger and opportunity. They do not know that they are Homo. They do not know they are at the beginning of anything. They are just living, watching the land, learning from each other, striking stone upon stone, and in that sound beginning to carve a new path for their descendants. Soon enough, another figure will step onto that path, taller, longer-legged, with a bigger brain and a wider range. Homo erectus, the traveller, the firekeeper, the one who will take this experiment and carry it far beyond the valleys where it began. The taller figure appears first in fragments, a skull cap here, a jaw there, a limb bone, long and straight, buried in layers of ancient sediment, different sites, different ages. But when scientists begin to compare them, a pattern emerges. Around 1.9 million years ago, a new kind of hominin is walking the African landscape. Compared to Homo habilis and the Australopithecines before them, they are bigger, stronger, and built for distance. Their brain is larger too, roughly 800 to 900 cubic centimeters in many examples, with some later individuals growing beyond that. The face still projects forward, the brow ridge is heavy, but the overall skull is more elongated, more streamlined, as if shaped for a different kind of life. They are given a name, Homo erectus, upright human. Though by this point, upright walking is not new. What is new is the way the body has been reshaped around that walk. If we could see one of them on the move, the differences would be unmistakable. The legs are long relative to the arms. The pelvis is narrower and more like our own. The chest is barrel-shaped, not the conical, flared ribcage of earlier hominins. The feet are fully adapted to bipedalism, strong arches, compact toes, a big toe aligned with the others instead of grasping branches. This is a body that, for the first time in our lineage, really looks like it was designed to travel. Long legs mean fewer steps per distance. A more efficient, springy foot means less energy lost with each stride. The gluteal muscles, the ones at the back of the hips, are positioned to stabilize the trunk as it moves. Even the placement of the head, balanced differently on the spine, contributes to an efficient, steady gait. Some researchers think Homo erectus may have been one of the first true endurance athletes of the animal world. Not fast sprinters like cheetahs, but tireless walkers and runners. On hot days, When other predators had to rest in the shade, these hominins, with their relatively hairless skin and ability to sweat, might have kept going, tracking prey over long distances until the animals were exhausted. This idea, known as persistence hunting, is still debated. Direct evidence is hard to find, but the combination of body shape, climate, and ecology makes it at least plausible. Whether or not they regularly ran animals to collapse, one thing seems likely. Homo erectus could cover ground in a way no hominin before them could match. And once you can go farther, the world begins to open. In East Africa, around places like Kubi Fora and the Turkana Basin, fossil layers reveal a changing environment. Forest patches give way to more open grasslands and mixed habitats. Lakes expand and contract. Rivers shift their courses. In this patchwork world, being able to move efficiently between water, shade, and food is a powerful advantage. We can imagine small bands of Homo erectus setting out at dawn, their long shadows stretching over the grass. They move steadily, not rushing, conserving energy. Children walk at the centre, older individuals and alert adults at the edges. On the horizon, herds of antelope drift across the plains. Far away, vultures circle, marking the place where a predator's kill lies. These hominins still use stone tools, but something about those tools has changed too. The simple flakes and cores of the older one tradition do not disappear overnight, but alongside them, a new kind of artifact begins to appear, the Acheulean hand axe. These tools first emerge around 1.7 million years ago and will remain in use with variations for more than 1 million years. That alone makes them one of the most enduring technologies in human history. At first glance, a hand axe looks like a teardrop of stone, roughly the size of a human hand. Both sides are flaked, carefully shaped to meet in a symmetrical, sharp edge all around. Some are pointed at one end and rounded at the other. Others are more oval, but what they share is deliberate form. To create one, you can't just strike a rock randomly. You have to have a plan. You start with a good raw material. Flint, chert, fine-grained basalt. You knock off large flakes to establish the basic shape. Then you turn the core in your hands, studying it, seeing where the next blow should fall. With each strike, you thin the edges, refine the symmetry, straighten the lines. It is a slow dialogue between hand, eye, and stone. The finished tool is versatile. It can chop wood, butcher animals, dig for tubers, scrape hides. It might even serve as a kind of all-purpose knife, carried for weeks or months and resharpened when needed. In some sites, hand axes have been found made from stone types not local to the area, suggesting they were carried over long distances, maybe even valued as personal possessions. This is not just about sharp edges anymore. It is about a mental template that can be held in the mind and reproduced. Homo erectus, it seems, is beginning to think in more extended sequences. Not just break rock, sharp edge appears, but shape rock in this particular way, and you will have a reliable tool that can serve many tasks. Teaching and imitation may have become more complex. Younger individuals could watch an experienced napper at work, then try to copy the pattern. The idea of how a tool should look becomes something that can be transmitted across generations. At some sites, such as the famous locality of Olorgesailie in Kenya or Boxgrove in England, large numbers of hand axes have been found together, scattered across ancient surfaces. Some are perfect. Some are half-finished or broken in the making. These places may have been old landscapes of work and living, where Homo erectus groups processed carcasses, shaped tools, and perhaps lingered for days or weeks before moving on. And somewhere amidst these tools, another possibility glows faintly in the archaeological record. Fire. Fire is one of those turning points that is easy to see in theory and hard to pin down in practice. Natural fires have always existed, started by lightning, volcanic activity, or dried vegetation igniting under the right conditions. Many animals respond to them instinctively, fleeing, scavenging the burnt ground for roasted seeds or newly exposed prey. The step from watching to using is small in imagination, but in prehistory it may have taken many hundreds of thousands of years. By about 1 million years ago, there are sites, such as Wonderwerk Cave in South Africa, that show traces of what might be controlled fire. Ashes and burnt bone deep inside a cave, where wildfires are unlikely to have reached unaided. At Gesher Benot Yaakov in Israel, around 780,000 years old, there are clusters of burned flint and seeds that some researchers interpret as repeated, localized hearths. Not everyone agrees on every case, and the earliest secure evidence for regular habitual fire use remains debated. The record is patchy, eroded, often ambiguous. But by the Middle Pleistocene, perhaps somewhere between 800,000 and 500,000 years ago, most scientists think that some Homo erectus populations and closely related forms were at least occasionally tending and using fire. What would that have meant? At the simplest level, fire brings warmth and light. In cooler nights or at higher elevations, a controlled flame can mean the difference between life and hypothermia. Light extends the day, allowing more time for tool-making, social interaction, or shared vigilance against predators. Fire also changes food. Raw meat and roots are hard work for teeth and guts. Cooking softens them, breaks down toxins, and releases more energy. Some researchers have proposed that the increased calorie gain from cooked food may have supported the growth of larger brains and bodies, freeing hominins from the constraints of endlessly chewing, tough, raw diets. Again, no single site gives us a perfect, unbroken story. But the combination of anatomical change, smaller teeth, modified jaws, and scattered hints of fire fits a broader picture in which Homo erectus and its relatives are gradually shifting their relationship with food, heat, and shelter. Around a fire, camp life itself might have changed. Imagine an evening on an ancient lake shore. The sun has set, but a circle of orange light flickers against stones and low branches. Shadows lean in and out as figures move. There is the smell of smoke, the crackle of wood, the soft murmur of whatever vocalizations these hominins share. A carcass, hunted or scavenged during the day, is being processed. Hand axes slice through muscle. Bones are cracked with hammerstones. Some pieces of meat may be laid near the coals. Children watch, reaching for scraps, learning without words what each gesture means. In this space, the group can relax just a little. Predators may hesitate to approach the flame. Faces are illuminated, expressions are easier to read. Social bonds can deepen in these safe zones of light. We do not know exactly how complex Homo erectus social structures were. There are no written records, no preserved conversations, but their success hints at something important. This is a species, or a cluster of closely related species, that would not only survive in Africa, but leave it. By about 1.8 million years ago, their bones and tools appear far beyond their birthplace. In places like Dmanisi in Georgia, at the edge of Eurasia, we see early representatives of this travelling lineage. Smaller-brained than later Homo erectus, but clearly part of the same broader experiment. Soon, traces of similar hominins and Acheulean tools show up across parts of the Middle East, into India, and eventually as far as Southeast Asia, and perhaps northern China and Java. This is the first time in our story that hominins truly become a continental presence. Leaving Africa did not happen in a single heroic migration. It was probably a slow, uneven process, stretched across thousands of generations. Groups followed rivers, coastlines, and game trails. Climate shifts opened and closed corridors of grassland and woodland. Some populations may have reached new regions and failed, disappearing from the record. Others adapted, learned the patterns of strange seasons and unfamiliar prey, and stayed. Why does this expansion matter? Because each new landscape demands new answers. Different animals to hunt or scavenge, different plants to recognize and remember, different rock types to learn, what breaks well, what doesn't, where to find it, different predators, from big cats in Africa to bears and large canids in Eurasia. To cope with all of this, Homo erectus needed not only sturdy bodies and sharp tools, but flexible minds and social cooperation. Larger home ranges and more fluid movement patterns likely increase the size of social networks. Groups might split and rejoin seasonally, exchanging individuals, mates, and knowledge. A person born in one valley might, through a chain of kin and allies, find themselves years later on the far side of a mountain range, carrying with them memories of distant waterholes or useful stone outcrops. Genes flowed along these pathways too. Over time, this constant mixing and spreading may have helped maintain resilience. When drought struck one area, individuals could move to another. When disease or scarcity weakened a local group, cousins in a nearby region might offer a lifeline. Homo erectus, then, is not just a new body shape, it is a new way of being in the world. Wider-ranging, more connected, more dependent on shared skills and learned behavior. For more than 1 million years, in various forms and regions, this lineage would endure. Through glacial cycles and shifting lakes, through forest expansions and grassland retreats, they would keep moving, keep shaping stone, perhaps keep tending small, precious fires. And in that long span of time, under different skies and across changing continents, the foundations are laid for everything that comes after, for larger brains, for richer cultures, for the many branches of humans that will eventually share the planet at once. But before those branches unfold, the world itself will grow more complex. Climate will swing more sharply. New hominins will appear, each carrying echoes of Homo erectus, but taking the experiment in different directions. Soon, there will not be just one kind of human. There will be many. The world keeps changing. The Earth's tilt wobbles. Ice grows and melts at the poles. Oceans rise and fall. In Africa and across Eurasia, climates swing between wetter and drier, cooler and hotter. Forests advance like slow green tides, then retreat. Grasslands spread, then fragment. Lakes swell into broad inland seas and then shrink back into muddy basins. Homo erectus has already learned to ride these changes, but now the pressure begins to carve the lineage into branches. Evolution is not a straight ladder, with one species neatly replacing the last. It is a tangled, shifting tree. Some branches stretch far and flourish for hundreds of thousands of years. Others bud briefly and then end, leaving only a few bones and a mystery. Somewhere between about 800,000 and 600,000 years ago, a new kind of hominin emerges from within this Homo erectus-like world. The body is familiar, tall, long-legged, clearly built for distance, but the skull tells a deeper story. The brow ridges are still pronounced, but the brain case is larger, often over 1,100 cubic centimeters, and sometimes approaching the size of our own. The face is a little less projecting. The jaw is strong. The teeth are smaller than in earlier species, but still robust. Many of these fossils are grouped under the name Homo heidelbergensis, after a famous jawbone found near Heidelberg in Germany. Others go by related labels like archaic Homo sapiens or regional variants, depending on who is doing the classification. Not everyone agrees where the boundaries lie. But whatever we call them, these middle Pleistocene humans represent an important turning point. They seem to sit close to the base of several later branches, perhaps including Neanderthals, Denisovans, and eventually us. Their world is harsher than the one their ancestors knew. Glacial cycles become more extreme. In cooler periods, ice sheets creep southward across northern Europe and Asia. Temperate forests thin out. Open, cold steppe spreads. In Africa, rainfall patterns shift. Some regions become mosaics of woodland, scrub and savanna. Others dry into near desert. Populations of humans and animals alike are sometimes connected across wide areas, and sometimes cut off in pockets of suitable habitat. Isolation is one of evolution's favourite tools. When groups are separated by mountains, ice, deserts, or rising seas, the genes in each group follow their own path. Over thousands of generations, faces change, bodies adapt, behaviours diverge, and when climates swing back and barriers soften, those once isolated groups may meet again, mixing, competing, or simply passing each other by. In Europe and Western Asia, some communities of these mid-period humans adapt to colder, more seasonal climates. They become stockier, their bodies better at conserving heat. Their faces evolve distinct shapes. Over time, these populations may give rise to the Neanderthals. In Africa, other groups face different pressures, shifting rainfall, episodic droughts, varied ecologies from dense forest to open grassland. They follow herds, exploit wetlands, move up into highlands and down into rift valleys. Their bodies and brains track a different course, one that will eventually lead toward Homo sapiens. Meanwhile, in other corners of the Old World, still more variations appear. In southern Africa, in a deep cave system called Rising Star, small-bodied hominins leave behind a surprising legacy. Discovered only in the last decade, they are given a new name, Homo naledi. Their skulls are relatively small, with brains closer in size to early Homo than to later species. Their shoulders and fingers suggest strong climbing abilities, but their feet are remarkably human-like, and their hands, though curved, are capable of precise grip. Even more intriguing is where their bones are found. Deep within the cave, in narrow, hard-to-reach chambers, accumulations of skeletal remains suggest that bodies may have been deliberately placed there. If this interpretation is correct, and not everyone agrees, it hints that even small-brained hominins might have engaged in complex behaviours around death. Our old assumptions that bigger brains always mean richer culture become less certain. This is one of the themes of this period. Complexity everywhere you look, and a fossil record that reveals it only in fragments. Across Africa and Eurasia, hunting strategies evolve. Earlier hominins could scavenge and occasionally take down medium-sized prey, but these later forms seem more consistently involved with large animals. In some sites associated with Homo heidelbergensis like humans, there are accumulations of big-game bones, rhino, elephant, large bovids, alongside sophisticated stone tools. At places like Boxgrove in England or Schöningen in Germany, carefully shaped wooden spears have been found, over 300,000 years old, balanced and pointed, apparently used to hunt large animals in coordinated groups. To bring down such prey, strength alone is not enough. You need planning, choosing the right place for an ambush, reading the wind, positioning hunters, timing the rush. You need communication, whether through gestures, vocal calls, or something approaching early language. You need trust, to stand your ground as an animal several times your size charges toward you, knowing that others will hold the line. Shelters change too. We still see no permanent houses, no villages in the modern sense, but there are hints of more structured living spaces. At some open-air sites, stone tools, animal bones and hearths cluster together in patterns that suggest designated activity areas. Places for butchery, for napping, for sleeping close to the fire. In cooler climates, some groups may have built simple windbreaks from branches and hides, or taken over natural rock shelters more systematically, returning season after season. Fire becomes more central. By this time, many researchers think that at least some human groups are using it regularly. Hearths appear as lenses of ash and charcoal. Burned bone and heated stone show up in layers again and again. Fire warms cold nights, opens up new environments, and changes the rhythm of daily life. Daylight no longer strictly sets the limits of what can be done. Around embers, tasks can continue. Stories, however simple their form, can be shared, and social ties can be reinforced. And all the while, the tree of humans is branching. In some regions, different human species may have lived surprisingly close to one another. It is possible to imagine a river valley in Africa where one slope is home to a population with larger brains and more advanced tools, while a neighbouring plateau shelters a smaller-bodied group like Homo naledi, each following its own way of life. We do not yet have a clear archaeological scene showing such an encounter, but the timelines overlap. So do some of the territories. In Southeast Asia, another story unfolds. Descended from earlier migrants, a diminutive species known as Homo floresiensis, the hobbits of Flores Island in Indonesia, appears much later with a curious mix of primitive and more derived traits. Their brains are small, their bodies short, yet their stone tools suggest capable hands and minds, navigating island forests and hunting small elephants and giant rats. Again, the straight-line picture blurs. Sophistication and brain size do not march in simple lockstep. These overlapping forms remind us that for long stretches of time, human was not a single thing. Different species, some with larger brains, some with smaller, some adapted for cold, others for heat, some long-limbed, others compact, all shared the planet, sometimes at the same moment, often on the same continents. Yet we must be careful about the stories we tell. The fossil record is like a book with most of its pages torn out. Bones survive only under special conditions. Many individuals lived and died with no trace left in the sediments we can reach today. Entire populations might have come and gone, leaving little more than a handful of teeth or a fragment of jaw. Because of this, interpretations shift as new finds appear. A skull once thought to belong to one species may be reassigned to another. A jawbone can redraw a branch of the family tree. A new dating method can push a species' existence back by hundreds of thousands of years, forcing us to revise who could have met whom and where. Homo heidelbergensis is a good example. Some scientists see it as a single widespread species, ancestral to both Neanderthals and modern humans. Others argue that the fossils grouped under that name actually represent multiple lineages, already diverging region by region. In Africa, some mid-period fossils are instead called early Homo sapiens, emphasizing continuity with our own species. In Europe, similar-looking bones might be labeled as early Neanderthals. None of these labels are absolute. They are our best attempts to bring order to a messy, continuous process. And yet, even with that uncertainty, a pattern emerges. Climate shifts fragment populations. Fragmentation allows different traits to spread and settle in different places. When conditions change again, some of those populations expand, sometimes replacing, sometimes mixing with their neighbours. Over hundreds of thousands of years, this cycle repeats. Diversity grows, shrinks and grows again. Within groups, social worlds deepen. Hunting becomes more coordinated. Toolkits more regionally distinctive. Some regions favour heavy-duty hand axes and large cutting tools. Others see more flake-based technologies, smaller, sharper implements tailored to specific tasks. These differences might reflect available stone, prey types and cultural traditions passed down through generations. We can picture an evening on a Pleistocene plain. A band of humans, not quite like us but getting closer, returns from a successful hunt. Meat is shared, bones are cracked for marrow, fat hisses as it drips into the flames. Nearby, leaning against a rock, a row of hand axes sits within easy reach, each one slightly different in shape, reflecting the hand that made it and the local style of the group. Far away, across a mountain range or a stretch of forest, another band tends their own fires. Their tools have a different shape. Their words, if they have them, sound different. Their rituals, if rituals exist, follow other rhythms. They may never meet, or, in some distant generation, their descendants might cross paths, exchanging mates, techniques, stories, genes. From our perspective, looking back, all of this complexity leads toward a future moment when one branch, our branch, will spread across the globe. But in the time we are visiting now, nothing is predetermined. To the beings living through it, there is only the immediate concern of food, shelter, safety, and the quiet, ongoing experiment of what it means to be human in many different ways at once. Out of this crowded, branching tree will emerge the more familiar figures of Neanderthals and Denisovans, and eventually Homo sapiens. But to understand them, we must remember this deeper background, a world where there was never just one kind of human, but many, shaped by ice and drought, by mountains and seas, by chance and by the choices made with stone, fire, and fragile, evolving minds. From this branching, shifting forest of human forms, one line in particular begins to stand out in the cold lands of the north. In Europe and Western Asia, over hundreds of thousands of years, a distinctive kind of human takes shape. Their ancestors have already weathered repeated glacial cycles. Each swing of the climate cuts populations off, then reconnects them. In this constant rhythm of isolation and contact, a new form stabilizes, fine-tuned for a harsh Ice Age world. We call them Neanderthals. If you were to meet a Neanderthal on a quiet winter day, the first thing you might notice is their build. They are not the slouching, brutish caricatures once drawn in old textbooks. They are powerful, compact, and balanced, like elite athletes adapted for cold. Their bodies are shorter and stockier than those of many modern humans. Broad chests, thick ribs, strong muscular limbs. Their hands are large and capable, with stout fingers that can grip stone and wood with immense force, yet still perform delicate tasks. Their bones are dense, scarred with the marks of a physically demanding life. Their faces are different from ours, but not unrecognizably so. The mid-face projects slightly forward. The nose is large and wide, likely helping to warm and humidify frigid air before it reaches the lungs. Above the eyes, a continuous brow ridge forms a prominent arc. The back of the skull sweeps out into an occipital bun, a distinctive bulge. Yet inside that skull, the brain is at least as large as, and sometimes larger than, the average modern human brain. These are not half-formed minds. They are another way that intelligence can look. The world they inhabit is challenging. During colder phases, vast ice sheets cloak northern Europe. South of the ice, tundra and steppe stretch for thousands of kilometers. In warmer interludes, forests return, birch, pine, oak. But the climate remains variable, unforgiving. Herds of mammoth, woolly rhinoceros, bison and reindeer migrate across these open spaces. Cave lions and hyenas patrol the shadows. In this landscape, survival means reading the seasons, the animals, the changing routes of rivers and ice. Neanderthals are hunters. Evidence from many sites shows that they do not merely scavenge the leftovers of predator kills. They take on large animals directly. At certain caves and open-air camps, layers of sediment are packed with the bones of big game, often with cut marks and breakage patterns that suggest organized butchery. In some sites, the ages of hunted animals cluster in ways that hint at selective targeting, prime adult individuals, not just the weak or the old. This suggests planning and strategy, choosing the right time in a migration, driving animals toward natural traps, coordinating positions. Spear points associated with Neanderthals often show impact damage consistent with close-range thrusting. This is dangerous work, face-to-face with massive prey. The injuries on their skeletons echo this life. Many Neanderthal bones show healed fractures, ribs, arms, skulls, patterns reminiscent of modern rodeo riders or contact sport athletes. These are bodies that have been knocked down and have gotten back up again. The key word is healed. Someone helped them survive long enough to mend. This is one of the quiet, powerful clues to Neanderthal social life. We find individuals who lived for years despite serious disabilities. A man with a withered arm and severe joint disease, a person with deformities that would have made independent hunting almost impossible, yet they lived into older adulthood. That implies more than momentary cooperation. It suggests sustained care. Food shared with those who could not hunt. Shelter offered to those who could not keep up. Time and energy invested in individuals whose material contribution may have been limited, but whose presence clearly mattered. So when we picture Neanderthals, we can imagine not just hunters in the snow, but families gathered around a fire, children learning to flake stone by watching elders, old injuries pressed close to the warmth, stories, however they were structured, moving from mouth to ear in the glow of embers. Their tools for a long time were grouped under a single label, Mousterian. In older narratives, these were seen as static, unchanging, a sign of limited creativity compared to the later, more varied toolkit of Homo sapiens. But as more sites are studied, a different picture emerges. Neanderthal toolkits are subtle, regionally varied and adapted to local needs. They often favoured a technique called the Levallois method, in which a stone core is carefully prepared so that a flake of a particular shape can be struck off in a single controlled blow. This requires a mental blueprint of the final tool, held in mind through a sequence of steps. Planning, abstraction, and fine motor skill come together in each strike. Their tools are not just hand axes. There are scrapers for working hides, points for spears, denticulated edges for sawing and notching. They select different raw materials depending on the site: flint, chert, quartzite. At some locations, these stones have been transported many kilometres, hinting at knowledge of distant sources and perhaps regular movement across a familiar home range. And then there is fire. Neanderthal sites consistently show hearths, patches of ash and charcoal, reddened soil, burned bone. In cold environments, fire is not optional. It shapes daily rhythms, drying skins, hardening wooden spear tips, cooking meat, providing light for tasks after dark. Around the fire, conversation, if they had structured language, could unfold. If language was not fully like ours, then at least complex vocal communication, gestures, shared attention. Did Neanderthals have language in the modern sense? We cannot hear their voices, but we can look at clues. Their vocal tracts likely differed somewhat from ours, but the shape of the hyoid bone in at least one Neanderthal suggests the physical capacity for a range of sounds, not unlike our own. The inner ear bones, which help process certain frequencies, are also similar to ours. The FOXP2 gene, involved in aspects of speech and language in humans, appears in a derived form in Neanderthals as well. None of this proves full grammatical language, but taken together, it makes the idea of silent, grunting Neanderthals increasingly unlikely. They may have had languages, plural, evolving and changing across regions and time, as ours do. Signs of symbolic behaviour add another layer. At several Neanderthal sites, archaeologists have found pigments, especially red and black minerals like ochre and manganese dioxide, collected and sometimes processed. In some cases, there is no obvious practical function, suggesting that colour itself may have been meaningful. There are hints of personal adornment. At sites in Spain and elsewhere, shells with traces of pigment and possible perforations have been found in layers associated with Neanderthals, along with bird bones and feathers that may have been selected for display. A set of stalagmites arranged in circular structures deep within the Bruniquel cave in France, dating to over 170,000 years ago, has been attributed to Neanderthals. The purpose is unknown. Ritual, shelter, symbolic marking of a special place? We can only speculate, but the effort involved in working so far from natural light suggests intention beyond simple survival. Burial is another window. Several Neanderthal skeletons appear to have been deliberately placed in pits, sometimes in a flexed position, sometimes with minimal grave goods. In Shanidar Cave in Iraq, one famous individual, once thought to be buried with flowers, is now more cautiously interpreted, but the broader pattern remains. Bodies that seem to have been carefully handled after death. Whether these practices reflect beliefs about an afterlife, social memory, or simply a respectful way to deal with the dead, they imply that death was not just an event, but something communities responded to together. While Neanderthals were developing and living out their history across Europe and Western Asia, another, more shadowy branch of the human family tree existed farther east. We call them Denisovans, after the cave in Siberia where the first clues were found. But unlike Neanderthals, Denisovans have left us almost no bones. A finger bone from a young girl, a few teeth, unusually large and robust, a fragment of skull. That is nearly all, at least for now. Yet from these fragments, a remarkable story has been uncovered. Ancient DNA, extracted from the Denisova cave fossils, has revealed an entire genome distinct from both Neanderthals and modern humans, yet closely related to Neanderthals as a sister group. Genetically, we can see traces of Denisovans scattered across Asia and into Oceania. People living today in parts of East Asia, Melanesia, and Australia carry small but significant portions of Denisovan DNA. In some populations of Papua New Guinea and surrounding islands, the percentage can reach several %. These genes are not just neutral echoes. Some Denisovan-derived variants seem to affect how our bodies handle altitude, immune responses, and other physiological traits. For example, a gene variant associated with improved adaptation to low oxygen at high elevations in modern Tibetan populations appears to have been inherited from Denisovans or a closely related group. In this way, encounters long ago still shape how some of us breathe on mountain slopes today. The same is true of Neanderthals. Almost all people whose ancestry lies outside of Africa carry a small fraction of Neanderthal DNA, usually around 1 to 2%, sometimes a bit more. Different individuals carry different pieces, so if you add them all up across the global population, a significant portion of the Neanderthal genome still exists, scattered among billions of living humans. These segments affect a range of traits, aspects of skin and hair, immune system responses, even some subtle influences on metabolism and brain function. Not all of these effects are positive. Some Neanderthal variants may increase the risk of certain conditions in modern environments. But the important point is that Neanderthals did not simply vanish without a trace. Part of them is literally within us. How did this mixing happen? The simplest answer is also the most human one. When groups met, Neanderthals, Denisovans, and Homo sapiens, they sometimes formed relationships, however brief or enduring. Mates were chosen or taken. Children were born. Some of those children were fertile, their descendants folded into expanding populations. There were likely many such contact zones, shifting over thousands of years as climates changed and ranges expanded or contracted. On a valley floor in the Levant, in a forest edge in Central Asia, on a windswept steppe in Siberia. Different kinds of humans meeting, watching, perhaps trading, perhaps competing, perhaps sharing more than we once imagined. And yet, today, only one branch remains as a clearly separate species: us, Homo sapiens. Neanderthals disappear from the fossil record around 40,000 years ago. Denisovans, as far as we can tell, fade out sometime in a similar window, though the exact timing and places remain murky. Why? There is no single tidy answer. It was not a simple story of superior modern humans marching in and instantly replacing all others. The timelines show long periods of overlap. In some regions, Neanderthals had already retreated or diminished before large numbers of Homo sapiens arrived. In others, coexistence seems to have lasted thousands of years. Climate played a role. The period around 50,000 to 30,000 years ago saw rapid climatic fluctuations in Eurasia. Environments shifted quickly. Forests gave way to steppe, then back again. For populations already small and scattered, each swing could be devastating. Genetic evidence suggests Neanderthals often lived in relatively low numbers, with less overall diversity than Homo sapiens populations in Africa. That makes them more vulnerable to bad luck, disease, resource failures, a few consecutive harsh winters. Competition also mattered, as Homo sapiens arrived in Eurasia, bringing different technologies, perhaps more flexible social networks and wide-ranging trade and alliance patterns. The ecological niches where Neanderthals had long thrived began to change. Prey animals might have been hunted in new ways. Key territories might have shifted hands. In some areas, interbreeding may have blurred boundaries until distinct Neanderthal groups were absorbed into larger human populations, their physical traits diluted even as their genes persisted. We should be cautious about saying too much. Our view is still patchy. New discoveries could shift the balance of these explanations. What seems increasingly clear, though, is that Neanderthals and Denisovans did not fail in any simple sense. They survived and adapted through hundreds of thousands of years of dramatic climate swings. They raised children, made tools, used fire, and navigated complex landscapes long before our species left Africa. Their disappearance is less a story of sudden replacement and more a slow, uneven fading, shaped by climate, demography, chance, and the arrival of another human form that would over time become numerically dominant. When we look back now, from our comfortable distance, it is tempting to see Neanderthals and Denisovans as steps on a path leading inexorably to us. But evolution does not work with goals in mind. They were not rehearsals. They were complete, successful ways of being human in their own right, for as long as their worlds allowed. And when those worlds changed, parts of them stayed, in our DNA, perhaps in echoes of behaviours and traditions passed through countless generations, in the shape of a nose that handles cold air a little differently, or in the way a particular immune gene responds to a pathogen. In the deep night of a glacial plain, under a sky brilliant with unpolluted stars, a group of Neanderthals huddles near a glowing hearth. Far away on another continent, our own ancestors sit by their own fires, unaware that one day their descendants will share stories about these other humans, trying to understand who they were. Soon those distant fires will draw closer. Homo sapiens will step out of Africa and into a world where Neanderthals and Denisovans already walk. Their meetings will change us all. To follow that part of the story, we turn now to the emergence of our own species. In the deep time before cities, before metal, before names written on clay or paper, there is a different kind of turning point. Not a sudden spark, not a single birthplace, but a long, slow brightening scattered across a continent. Africa. For millions of years it has been the cradle of hominins, of upright walkers, tool makers, fire keepers. Now, between shifting lakes and drying forests, among rocky plateaus and winding river systems, a new form of human begins to take shape. It does not arrive all at once. It gathers, like dawn. If we could watch this story unfold in fast forward, we would see faces changing in subtle ways, heavy brows softening, skull vaults rounding, faces becoming a little flatter, a little lighter, bodies keeping the strength of earlier humans but with more gracile bones, more refined hands. These are not yet fully us, and yet they are not quite the people who came before. Lineages branch and fade and mix again. Populations separate for a time, then reconnect, trading genes and ideas across valleys and savannas. Somewhere in this braided network, what we call Homo sapiens begins to emerge. For a long time, scientists imagined our origin as a single, sharp event, a small group in one favoured valley, a Garden of Eden, where modern humans suddenly appeared and then spread outward. As new fossils and new dates accumulated, that picture grew blurry. Bones from different corners of Africa began to speak in overlapping times and similar shapes. In the north, at Jebel Irhoud in Morocco, fragments of skulls and jaws were first unearthed in a mid-20th century limestone mine. At the time, they were hard to place, too modern to be ancient, too ancient to be fully modern. Decades later, with refined dating techniques, their age settled around 300,000 years. The faces are strikingly familiar, flat, tucked under, with small, delicate teeth. The brain cases, though, are long and low, not yet the rounded globes we see today. It is as if we are looking at our species in profile, halfway through a thought. Far to the east, near the Omo River in Ethiopia, other remains tell a related but slightly later story. Homo sapiens fossils, dated to roughly 200,000 years ago, show cranial shapes much closer to ours. In southern Africa, at Floris Bad, a partial skull around 260,000 years old offers yet another blend of archaic and modern traits. In other sites, Herto in Ethiopia, Claces River mouth along the southern coast, and scattered localities across the continent, pieces appear, each a little different, each bearing a family resemblance. Taken together, these finds hint that there was no single birthplace, no lone founding population. Instead, early Homo sapiens-like groups may have been spread across Africa, separated by distance and habitat, but still connected at intervals. Rivers shift, grasslands open and close, corridors appear and vanish with the climate. People move, meet, have children. Features that arise in one region spread slowly to others, mixing with local variations. Over hundreds of thousands of years, what we recognize as anatomically modern humans coalesces from this web of populations. Our emergence looks less like a tree with a single trunk, more like a braided river, channels dividing and rejoining as they flow. But bones tell only part of the story. Inside those gradually rounding skulls, the organization of the brain is changing, not necessarily exploding in size. By this time, brain volumes of some earlier species like Homo heidelbergensis are already within the modern range, but shifting in shape, in wiring, in how different regions interact. Subtle differences with enormous consequences. One visible clue lies not in fossils, but in how we live, the length of childhood. Modern humans are unusually slow to grow up. Compared to many other mammals and even other hominins, we spend a long time being small, dependent, and unfinished. Teeth in fossil jaws can be read like growth rings in trees. When researchers compare these growth lines across different human species, they find that earlier hominins often matured more quickly. In contrast, many early Homo sapiens specimens show patterns closer to our extended developmental timetable. A long childhood is costly. It means more years of feeding and protecting someone who cannot yet fully contribute to the group's survival. But it also offers something in return: time. Time for the growing brain to wire itself through experience. Time to absorb skills, languages, stories, social rules. Time to practice. In small bands spread across African landscapes, children watch. They watch stone being knapped, fibers twisted into cord, meat divided after a hunt. They watch who shares with whom, who leads when a path is chosen, who comforts a crying infant. Much of what they learn is not written or even formally taught. It is picked up through imitation, through play, through the subtle dance of attention between older and younger eyes. This is social learning, and in our species it becomes a dominant force. Behaviours do not have to be invented anew in each life. They can be copied, refined, passed on. Over generations, this creates something new in the world. Traditions. Tool styles vary between regions. Some groups favour long, slender points that can be hafted onto spears. Others develop tiny, precise blades, microliths, that can be combined into composite tools. The raw materials may be different, the shapes adapted to local prey or vegetation, but underlying them is the same pattern: knowledge built up over time and shared widely within groups. This capacity for building and transmitting complex traditions may be one of Homo sapiens' quiet advantages. Not a single mutation for intelligence, but a suite of traits: long childhoods, strong social bonds, flexible communication, that together allow information to accumulate rather than dissipate. As minds become more entangled with each other, another shift appears, first in hints and then in unmistakable traces. Symbolism. In southern Africa at Blombos Cave, layers dating to about 75,000 years ago hold pieces of ochre, iron-rich stone that can be ground into red pigment. On some of these pieces, lines have been carefully incised, crossing and crisscrossing in deliberate patterns. The designs are abstract, not pictures of animals or people, but they carry regularity, rhythm, repetition. Someone took time to make these marks. They were not sharpening a tool, they were making a sign. Nearby, archaeologists have found shells with tiny holes drilled through them, likely strung together as beads. Some are stained with pigment, as if they had once been coloured. Beads also appear in other sites of similar age: North Africa, the Levant, East Africa. Different materials, similar ideas. These are small objects, easy to overlook, but they tell us something immense. Humans are beginning to care about how they appear to other humans. Ornaments, pigments, markings on skin or hair or clothing. These may signal group membership, personal status, life events, or spiritual beliefs. Whatever their specific meanings, they belong to a world where identity is negotiable, where appearance can be chosen, where symbols stand for things that are not physically present. Communication expands with this symbolic layer. Gestures and expressions are supplemented by sounds more structured, more combinable. The anatomy of the throat and mouth in early Homo sapiens suggests a vocal range at least as flexible as our own. The brain areas associated with language, visible in endocasts, the impressions of the brain case interior, are well developed. We cannot hear their voices, but many researchers think that by the time ornaments and abstract designs appear, some form of fully grammatical language is likely already in place. With language, memory can be woven into narrative. Instructions can become explanations. warnings can become stories that outlast the original danger. Myths, perhaps in very simple forms at first, can spiral outward from nightly conversations around a fire. Over time, such stories shape behavior as powerfully as any physical barrier or predator. Meanwhile, bodies and minds honed in African ecologies are pushing outward. Our species does not leave Africa in a single heroic migration. Instead, there seem to have been multiple waves over long stretches of time. Genetic data suggests that small groups may have ventured into the Near East more than 100,000 years ago, leaving modest traces in both fossils and DNA. Some of these early excursions might have faltered, populations shrinking or being reabsorbed as climates shifted, and competitors, including Neanderthals, occupied nearby lands. Later, perhaps around 70 to 60,000 years ago, another expansion spreads more widely. People follow coastlines and river valleys, moving into Arabia, then deeper into Asia and beyond. Within Africa itself, Homo sapiens is already highly mobile. Populations move between regions, tracking seasonal resources, responding to droughts and wet phases. Stone, shell, and pigment, found far from their sources, hint at exchange networks running across landscapes long before anyone steps onto another continent. All of this movement occurs against a backdrop of gradual emergence. There is no exact moment, no day or year or even millennium when we can point and say, here is the first true human. The line between archaic Homo sapiens and modern Homo sapiens is fuzzy, a human invention laid over a continuous process. If we could sit beside a riverbank 200,000 years ago and meet a group of these early people, we might recognize them instantly as kin. They would walk like us, gesture like us, cradle infants in their arms. Their faces might look a little different from those we see today in any given place, but then so do the faces of strangers we pass on a city street. Variation is normal. Humanity has always worn many shapes. What is new in them is not a sharp boundary, but a deepening pattern. Longer childhoods that allow more learning, more intricate social webs that can hold larger, more flexible groups together, brains tuned ever more finely to cooperation, empathy, and shared attention, tools diversified and specialized, symbols beginning to accumulate in beads, in pigments, in carved lines on stone and bone. From such quiet changes, a transformation gathers momentum. Across African nights, embers glow in scattered camps. Stories, in whatever early forms they take, pass from voice to listening ears. Children fall asleep to the sound of elders speaking about animals, paths, storms, losses, and the ways of the world. Above them, the constellations wheel on, unnoticed by the rocks and trees, but not by these new minds that can wonder, can remember, can imagine what does not yet exist. From these fires, from these long, slow centuries of learning and mixing and moving, our species steps into its long journey across the planet. The rise of Homo sapiens is not a sudden arrival, but a spreading awareness, a growing tapestry of bodies and ideas, and as we begin to walk out of Africa in earnest, carrying beads and blades and stories, the world itself will begin to change in ways no other animal has ever wrought. The earth is still quiet, wind drifts over grasslands, traces dunes along desert edges, presses against the ice sheets that fringe the northern world. Animals migrate, seasons turn, rivers carve their paths. For millions of years, these patterns have risen and fallen with almost no awareness watching them. But now, scattered bands of Homo sapiens are beginning to carry something new across the surface of the planet. Memory joined with intention. Wherever they go, they do not simply arrive, they adjust, they alter, they begin, slowly at first, to reshape the world that shaped them. In the north, the air is sharp and thin. Ice Age Europe and Northern Asia are cold landscapes of steppe and tundra, a mosaic of open grasslands dotted with shrubs, patches of forest clinging where they can. Herds of reindeer, bison, wild horses and mammoths move in great cycles, following the short summers and sparse grazing. For a tropical primate, this should be the end of the road, a wall of winter that says, no further. But modern humans do not meet the cold with fur grown from their own bodies. They borrow the warmth of others. They learn to work hides not just as rough wraps, but as tailored clothing. Needles, carved from bone and ivory, pierce skins with precision. Sinew threads them together. Parkas, leggings, mittens, layered footwear, all assembled with planning and skill. This is a quiet revolution. Clothing becomes not a simple covering, but a technology, an invented second skin that can be redesigned as conditions demand. Shelters follow the same logic. In some places, people build windbreaks of stone and wood covered in hides. In others, they may reuse the bones of large animals, arranging mammoth ribs and tusks into frames, then draping them with skins and turf to keep out the wind. Fires are tended carefully, banked overnight, their embers nursed from camp to camp like living seeds of heat. To survive here, groups must think ahead in time as well as space. They must know when herds pass through, when rivers freeze solid, when storms are likely. Food is not always available on the day it is needed. Meat is dried, fat is rendered, marrow is stored. People cache tools and supplies in particular locations, trusting that they, or others from their group, will find them again months later. This is planning on a scale deeper than a single day's hunger. Far to the south, under very different skies, other humans do something similar with a different set of challenges. Along coasts, tides rhythmically erase and redraw the line between land and sea. Here, people become specialists in reading waves and shorelines. They map in their minds the rocks that are exposed at low tide, the pools that trap shellfish, the seasons when certain fish spawn close to shore. Rafts of bundled reeds, dugout logs, or simple skin-covered frames may carry them short distances across inlets and channels. On these coasts, the sea becomes not a barrier, but a highway. Shells from distant shores show up in inland camps. Obsidian and flint, prized for their sharpness, travel hundreds of kilometres from their sources. The exchange is not always direct. Objects can pass through many hands, moving as gifts, trade, or tokens of alliance. These networks of movement and reciprocity weave different groups together into something larger than any single band. In forests, the challenges are different again. Dense canopies limit sight, but offer shelter and food. People here tune their attention to sound and scent, to the feel of bark and leaf under their fingers. They learn which plants are safe, which are poisonous, which heal. They fashion digging sticks to pry up tubers, snares to catch small animals, baskets woven from plant fibres to carry gathered food. The architecture of trees suggests new tools. Curved branches become bows, straight saplings become spear shafts. In deserts, knowledge is even more precious. Waterholes are remembered like constellations, each with its own character, its own seasonal cycle. Families carry in their minds maps that are not written but sung, recited, traced in stories. Travel happens at night or in cooler hours. Stones that glint in a certain way, the taste of dust on the tongue, the pattern of stars at a particular horizon. These become guides. The desert does not forgive ignorance, so ignorance is gradually pushed back. Across all these habitats, the same pattern appears in different forms. Homo sapiens is not tied to one environment. People do not just fit into a niche. They learn to build niches around themselves. They shape microclimates with fire, clothing, shelters, and stored food. They extend their senses with tools. They extend their memories with stories. And as they adapt to new worlds, they also begin to remake how those worlds behave. In Australia, after people arrive tens of thousands of years ago, fire is applied to the land with intention. Rather than waiting for lightning strikes and catastrophic wildfires, people may burn in controlled patches, reducing fuel, encouraging fresh growth, creating mosaics of different plant ages. This kind of landscape management, sometimes called fire stick farming, can attract herbivores to new grass and make travel easier through previously dense underbrush. Over time, such practices can influence which species thrive and which do not. Large animals, already stressed by climate shifts, often face a new pressure. Human hunting. In Australia, in the Americas, in parts of Eurasia, many of the biggest, slowest breeding creatures disappear within a few thousand years of human arrival. Mammoths, giant wombats, towering birds, saber-toothed cats, ground sloths. The precise causes are still debated: changing climates, habitat modification, hunting, or a mix of all three. But the pattern is hard to ignore. Wherever Homo sapiens settles, the roster of very large animals tends to shrink. This doesn't happen overnight. There is no single hunt that ends a species. Instead, there are countless ordinary decisions: which animals to pursue, which ones to spare, which patches of land to burn, which to leave. Each choice seems small. Together, over many generations, they tilt ecosystems into new shapes. All the while, inside human groups, another reshaping is underway, less visible from the outside, but just as transformative. It takes place in songs, in the quiet of caves, in the rhythms of speech. Deep underground, away from daylight, some people choose to leave marks. They travel into caverns lit only by flickering flames. On rough walls and undulating ceilings they paint, engrave and carve. Horses, aurochs, bison, reindeer, lions, bears, rhinos. Some figures are simple outlines, others are layered and shaded, using the curves of the rock to suggest muscle and movement. Handprints appear, sometimes in negative, pigment blown around a hand pressed against stone. Human figures are rarer, often abstracted or transformed. The reasons for this art are still unknown. Perhaps the images relate to hunting magic, to teaching, to initiation rituals, to beliefs about spirits and ancestors. Perhaps they served many roles, changing with context and teller. What is clear is that enormous effort was spent to make them. People brought pigments, lamps and ladders into spaces that were not everyday shelters. They chose particular walls, particular corners, as if certain places were more resonant than others. Elsewhere, objects carry meaning on a smaller scale. Beads of shell, bone, ivory and stone, pendants, decorated tools, engraved plaques. They travel on bodies and in bundles, visible as people move and meet. The patterns of these ornaments vary between regions, suggesting that style itself has become a kind of language. You can see, at a glance, that someone belongs to your group or to another. Shared symbols knit strangers into imagined communities, linking people who may never have met but recognize the same signs. Ritual gatherings amplify this effect. At certain times of year, scattered bands may converge at rich resource spots, river crossings, coastal lagoons, migration choke points. Here, information flows quickly. Songs are exchanged, marriages arranged, disputes settled, alliances strengthened. Stories stretch across generations, binding the dead, the living, and the unborn into one narrative line. In these stories, other humans appear too. When Homo sapiens expands into Eurasia, we do not step into an empty stage. Neanderthals are already there, deep-rooted in European and West Asian landscapes. Denisovans, known today mainly from their genetic echoes, dwell somewhere in the eastern highlands and forests. For a time, thousands of years, our lineages overlap. We don't know what these meetings were like. Perhaps sometimes they were tense, wary encounters on a hunting ground. Perhaps sometimes, in harsh winters or at shared shelters, there was cautious cooperation. We do know that, on more than one occasion, they led to children. The DNA of living people carries clear traces of these unions. Most non-African populations today have a small but measurable proportion of Neanderthal ancestry. Some peoples in Oceania and parts of Asia carry additional Denisovan ancestry. Specific genetic variants affecting things like immune responses or adaptation to high altitude appear to have come from these other human groups and then persisted because they were useful. In this sense, Homo sapiens did not simply replace other humans. Parts of their lineages folded into ours. Their genes and perhaps fragments of their cultures joined the braided stream of our species' history. Why, then, are we the only humans left? There is no single agreed answer. Our numbers may have grown faster, allowing our groups to recover from disasters more easily. Our social networks may have been wider, letting ideas and resources move swiftly between distant bands. Our tools and strategies may have been just slightly more flexible on average, giving us an edge in unstable climates. Or perhaps chance played a larger role than we like to admit. Small differences amplified by time. It's also possible that the question itself is too stark. Why did they die and we survive? May hide the reality that, in some subtle ways, they are still here, in our genes, in the tools and habits we borrowed and reshaped, in the shared human capacities that arose long before any of our species' names were written down. As the millennia pass, the human map grows denser. Australia holds its own rich tapestries of languages, songs, and land-based lore. Northern Eurasia fosters cultures that learn to move with reindeer and to fish through ice. The Americas, peopled from the north by migrants crossing exposed land or following coastal routes, become home to societies adapted to everything from Arctic cold to tropical rainforest, from high Andean plateaus to prairie grasslands. On each continent, people continue to hunt and gather, to burn and plant, to explore and settle. They build canoes and sleds, snowshoes and fish traps, pit houses and open camps. They domesticate plants and animals in some regions, while in others they remain mobile for much longer. There is no single path, no inevitable sequence. Instead, there is variation, experimentation, and an ongoing conversation between human minds and the environments they inhabit. What ties these distant lives together is not a shared technology or a uniform belief, but a deeper pattern, the ability to imagine futures and to act toward them together, the capacity to see a landscape not only as it is, but as it could be after the fire, after the hunt, after the next season's growth. The habit of carrying knowledge forward and outward, letting it accumulate rather than vanish. By 10,000 years ago, our species has touched almost every corner of the habitable world. Deserts, coasts, forests, mountains, ice edges, all hold stories told in human voices. Other human species are gone, their bones resting in caves and sediments, their names given by scientists long after the last of them walked under open sky. We remain inheritors of a long, tangled lineage. Why us, and not them? The earth offers no final verdict. It only shows the traces, footprints in ancient mud, hearths in long-collapsed shelters, pigments on stone, DNA in living cells. From these fragments we piece together possibilities, careful not to mistake our reconstructions for certainty. What we can say is this: When Homo sapiens spread across the world changed. Not in a single moment, not by a single decision, but through countless small acts, napping a new kind of blade, lighting a controlled fire, sharing meat, telling a story that makes tomorrow seem thinkable. In the soft dark of night, under stars that look much as they did then, those ancient decisions still echo. They shaped the landscapes our ancestors walked, and in subtle ways they shape the lives we lead now. When we pull back and look at this story as a whole, it begins far from anything we would recognize as human life. It starts with small, upright apes walking through mixed woodland and grassland, their worlds bounded by the distance they could travel on sore, bare feet. Australopithecus and its relatives experimenting with bipedalism, with hands free just enough to carry food, to throw, to shape crude tools. Then come the first members of our own genus, Homo habilis and its kin, with slightly larger brains and sharper stones held in more precise grips. From there, the line does not rise in a straight, proud staircase toward us. It spreads. Homo erectus strides out of Africa into Asia, into new climates, carrying fire and more refined technology. Other experiments appear and vanish. Robust hominins with massive jaws and teeth, mysterious small-bodied people like those of Flores, Neanderthals and Denisovans adapting to cold and altitude in their own sophisticated ways. For long stretches of time, several kinds of humans share the planet, overlapping in space, in habits, and eventually in genes. Our own species, Homo sapiens, emerges within this branching forest, not as a sudden arrival, but as a gradual change. Faces flatten, skulls round, brains rewire. Symbolic thought thickens, tools diversify, art and ornaments bloom, language deepens into syntax and story. We move, we mix, we leave Africa, and in the process the world bends around us. Ecosystems rearrange, species disappear, fire and farming and cities follow in time. And yet, for nearly all of this 4 million year span, there are no cities, no writing, no history books. Agriculture only appears around 10,000 years ago. What we call modern life, the last few centuries of industry, electricity, digital networks, occupies a sliver thinner than the edge of a stone blade. If Earth's history were a long night, our entire recorded story would be a brief flicker before dawn. Still, traces of that deeper night remain in us, in the arches of our feet and the shape of our hands, in the way children learn by watching and imitating, in our urge to gather around shared light, campfires, hearths, screens, and tell each other what was and what might be. Our genomes carry echoes of Neanderthals and Denisovans. Our myths remember floods, fires, and wandering ancestors. Our minds, restless and dreaming, still use very old tools: cooperation, curiosity, imagination. Some parts of this past we understand fairly well. Other parts are hazy, stitched together from fragments of bone and stone, from sediments and sequences of DNA. New discoveries arrive every year, sometimes overturning what seemed settled. Human evolution was not a simple ladder, but a tangled, living network, full of dead ends and quiet continuities. Many branches left no direct descendants, yet shape the conditions that allowed others to flourish. As you lie here listening, your body is one more link in that unbroken chain. Every breath, every heartbeat is supported by solutions worked out over countless generations. How to walk upright, how to digest cooked food, how to read another face and guess what it feels. You are recent, unimaginably recent in the measure of deep time. But you are also ancient, carrying with you the memory of forests and savannas, of ice edges and desert paths. If this long journey has kept you company tonight, or helped you drift a little closer to sleep, You can gently let me know by liking this video. If you feel like sharing, I'd love to hear where in the world you are listening from, your city, your region, or just the kind of sky above you right now. And if you'd like to wander through more stories of the past in quiet hours like this, you're welcome to subscribe and join again next time. For now, you can let the deep time behind you grow soft and distant and simply rest.